is our introduction to exercise 11.2 on measures of center and spread. We're going to start by continuing on with our previous topic in terms of what continuous distributions are. A quick reminder that our continuous distributions are focusing on the fact that it's not a specific value. So for example, it can be infinite range, we're just focusing on the intervals. And that the area under a graph determines the probability of a value being that specific, well, determined value. The value p of x, which is the solution of the equation here, where we have, and this is a section I'd like you to highlight, thank you. From negative infinity to p, f of x dx equals to q, is called the percentile of the distribution. Now the formula itself is not as pertinent, if I'm being honest. It's more so the fact that we should be able to understand what the question's asking for, because we'll apply the same thing in our normal distribution in the next lesson, which is like 40 minutes long, but let's ignore that. For example, to find the 75th percentile, and at this stage I'm assuming we're pretty comfortable with our 5-number summary, mean, median, mode stuff, and if you don't know that, please refer back to year 7 or 8 mathematics. To find the 75th percentile, we find the value of p when q, or the final answer, is 75%, or 0.75. And of course, on the other hand, if it's a median, we let q equal to 0.5. I'm going to demonstrate what that looks like with a diagram, just so that we're clear. There we go. All right, so if we're looking for our median, it makes sense that we want the middle bit of the data, right? In other words, we're saying, well, if I want to get to the middle, what does that area have to be? And if that is the area, what is that value, right? So essentially, we're writing from negative infinity to m of f of x dx equals 0.5, right? That's, of course, the median. We're saying, okay, I've got my data. I've got the fact that my values need to be 50% up until a certain point. What is that certain point, right? Now, of course, with our with our defined functions, most of the time we have, well, a defined domain. So from 0 to 300 or whatever it is, right? We're going to assume from negative infinity in our general formula. When you actually do the question, of course, consider the domain of the piecewise function. What this visually looks like is this, right? So let's say our curve or normal distribution looks like this, where we have the middle 50% of data, not middle, sorry, that should be, oh, I need to be careful with that wording there, not the middle, the first 50% of data being this section here. The reason why I'm being careful is because we'll later on do the middle 50% of data, which is your interquartile range, but I digress. From here, this is of course f of x, and this is of course x. This value here is represented by m. We're essentially saying, all right, at what stage does that give us the first 50% of data? Let's look at the example. Suppose the probability density function of weekly sales of topsoil, x in tons, is given by the rule f of x equals to, and for just the top, 2 bracket 1 minus x bracket, from 0 to 1, and everywhere else, or elsewhere, 0. Find the median value of x and interpret, okay? So essentially, again, we're looking for the probability of x being less than or equal to m being 0.5. And of course, it makes sense to say the other way around. If we wanted to write x is greater than or equal to m, that's fine. Of course, you'll have to flip your formula around, but we'll just stick to this one in the meantime. Of course, that is the same as saying 0 to m of 2 bracket 1 minus x dx equals to 0.5. And because we're gods at integration already, I'm going to go skip straight to that step of 2m minus m squared equals 0.5. That's just your integration. Okay. And then at this stage, you'd use a calculator, because I don't think anyone in this classroom, myself included, can do that in my head. So the answer ends up being m equals to 0.293 or 1.707. Now, does it make sense for me to say that my function has 2 medians? No, it doesn't make sense. One of them obviously isn't right. Which one is not within parameters, not to give the answer away? Thank you very much. Why is that not within parameters? Good. Exam situation, you need to clarify or make explicit why, right? So I'm going to write cross as, and then I'm just going to rewrite the domain, just to make it very clear to the assessor, hey, look, I know what I'm doing. And therefore, I'm going to type this out because I can't be bothered. In the long run, 50% of sales will be less than 0.293 tons. And if I wanted to give it a little bit more detail, 50% more than 0.239 tons. Right, that's what that means. But you guys know your median already. Alright, are we happy to move on? Do we need a little bit of time to copy that down? Okay, let's move on. Okay, measures of spread. Alright, the formulas that apply to our binomial discrete apply here as well. I'm going to rewrite them at the top. You don't have to do that. I'm just writing them here so I don't have to flick back all the time. So the variance of x equals to e of x squared minus mu. Remembering that mu is our mean, oh my gosh, our mean, or our e of x, and then squared. The sigma of x, or standard deviation, equals to the variance square rooted. And finally, one of the rules which will become extremely pertinent next, I was going to say episode, oh my gosh, next video will be this formula here. Again, you don't have to copy this. That last one there is just saying that the probability of the average minus 2 standard deviations to average plus 2 standard deviations is 0.95 or 95%. About 95%. Okay, let's do this. The question is pretty much exactly the same as we've done, the same function we've done in the previous lessons, alright? So I'm just going to go ahead and write those values out because we've already done them. I know that the e of x squared equals to 4 over 3 squared. Again, we did that previously. So that just becomes 16 over 9. Well, actually, you know what? Let's just leave it as 4 over 3 squared for now. It seems a bit easier in that case. The next one we want to use is our average, or our mean. Oh, apologies, that's the wrong one. I'm focusing on this one here, e of x squared, there we go, equals to, and we've already done that again, so that is 2. Okay, that should be a square there, my apologies, because it's our average squared, or expected value squared. Alright, so using that formula, right, remembering that it's going to be your e of x squared minus e of x squared, that just becomes variance of x equals to 2 minus 4 over 3 squared, which gives us an answer of 2 over 9. I skipped the step of solving it, but I'm sure you can do that yourself. The question's asking for the variance and the standard deviation. We've already got the variance. The standard deviation, of course, is just going to be the square root of the variance, which ends up being square root of 2 over 9, which is approximately 0.471. Again, that is a CAS step. Please don't stress about doing that in your head. A quick note, something you might be considering right now is, well, if we're doing the square root of 2 over 9, isn't it plus or minus 0.471? Something to note that I'd like you to write down as well. The variance cannot be less than 0, right? It can be 0, it can be positive, but cannot be less than 0. In the same vein, the standard deviation also must be positive or 0. Okay, let's move on. Question 22 says, determine the interquartile range of the random variable x, which has a probability density function, etc. A different function for once. So the interquartile range, remembering is that's from Q1 to Q3. Find the middle 50% of data. I'm just going to draw a diagram again, just in case. So that's our min, that's our max, that's our median. I'm just going to write MED for median. That's Q1 and that's Q3. We're just focusing on this part here. So let's find Q1 first. So the first 25%. This is applying the same, well, not the same formula, the same principle as the median equation. And I'm I'm just picking a letter, right? A is not conventional or anything like that. I'm just picking a letter from 0 to a of 2x dx equal to 0.25. Right, 25%, we're saying the first 25% of data. Right? Essentially, the value for this will give me from here to here. Okay? So that becomes, when you integrate it, etc., of course, that's x squared from 0 to a of, oh, I actually don't need to write dx, of 0 equals 0.25, which means that a squared equals to 0.25, and, well, a can't be plus or minus square root of 0.25 because, well, it has to go from 0 to 1. So I'm still going to write it out, and then I'll explain to the assessor that, well, I'm saying it can't be. So I'll say a equals to plus or minus square root of 0.25, where a is, or cannot, equal to negative 0.25 square root, as, oh, that should be a, apologies, because I'm defining it as a, because a must be between 0 and 1. Therefore, a equals to the square root of 0.25, which is just 0.5. So that's Q1. Q3 is exactly the same. Q3, where it's 75%, of course, means that we have from 0 to b. Now, you can do this the other way around as well. Instead of saying from 0 to b of 2x dx equals 0.75, you could go, for example, from b to, 1 of this, the same function, equals 0.25. That's just going to be the same thing. You're just going to be finding this section instead of this section, right? It doesn't matter. Either work. Solving this, you end up with b squared equals 0.75, which means that b equals to the square root of 0.75, though I'll write plus or minus, and again, I'll write b cannot equal to negative 0.75 squared rooted as 0 is less than or equal to b, which is less than or equal to 1. It's this weird balance or weird combination of the assessor knowing what they're meant to be doing, but you pretend like they're stupid, so you write everything out for them. And then finally, that is approximately 0.866. Therefore, your IQR, which is just going to be subtraction of both, is going to be 0.866 minus 0.5. So that's going to be approximately 0.366. The reason why I'm still using approximately is because, well, 0.866 was an approximation as well. Last page. Any questions before I move on? Okay, let's move on. Last bit of thing for this this exercise: transformation of probability density function. This will relate and link into the next exercise on our normal distribution. But for now, I'm going to focus on these key points here. I'd like you to highlight or underline the following. PDF of x plus b obtained by this, and so we get that. So for x plus b, that means we have our coordinates moved to the right one, or right b, sorry, units, and therefore the rule is f of x minus b. We love transformation, right? Okay, please don't hurt me. Alright, moving on, of course, the same idea is if we have a dilation of ax, we have this rule here, 1 over a, f of x over a. Yeah, that depends on the area, but we still have to note this section here. The extra 1 over a multiplied to preserve an area of 1. Remembering that the area under the graph needs to be 1, otherwise not a probability density function. Combining the two, of course, you have this rule right here. A of x plus b has the rule 1 over a, f of x minus b over a. I'm going to rewrite again some rules that we've learnt already. You don't have to write them down. E of ax plus b equals to a of ex plus b, and the variance of ax plus b equals to a squared times variance of x. These are formulas that are in your book already. Okay. Suppose that x is a continuous random variable with a mean of 10, and a variance of sigma squared equals to 2. Find e of 2x plus 1. Using that, of course, I know that it's going to equal to 2 times e of x plus 1. That's just using the first formula I wrote on the top right, which equals to 2 times 10 plus 1, which is 21. Any questions? Thank you for responding. Yes?
You know C outside of the effects.
Yep.
How come it didn't become 2 times the effects plus 1/2?
2 times e of x.
Plus 1/2.
Sorry, I can't really hear you.
When you took out the 2.
Using this formula. Yep.
Oh.
Yep. Okay. All right. Let's move on. Find the variance. Variance, we're going to use a different formula, though it's very, very similar, noting that a is always the coefficient of x, not just the first term. So that becomes the -3 squared times the variance of x, which is 9 times 2 equals to 18. Quick math. Okay. If x has a probability density function f, describe the rule of a PDF. I'm just going to abbreviate it. PDF G for 2x plus 1. We define it. A equals to 2, B equals to 1. I know that. Oh, apologies, I forgot to mention earlier. The reason why variance x is 2 is because the variance of x equals to sigma squared. Or if you square root both sides, the square root of variance is sigma. So I've just put that number back in. All right, back to this question. So we have described the rule of the PDF for 2x plus 1. I know the formula from above that we've highlighted is a of x plus, so a times x plus b becomes 1 over a f of x minus b over a. That's just the formula. So I can substitute it. I know that 2x, x, capital X, plus 1 goes towards g of x equals to 1 over 2 f of x minus 1 over 2. I'm just substituting the numbers right in. Questions? Okay.